In this video, I'm going to talk to you about relations. We'll also bump into two new terms along the way, which are the domain and codomain. A relation just shows how two or more objects are connected to one another. For example, who was Malaysia's first Prime Minister? It's Tunku Abdul Rahman. This is an example of a one-to-one relationship. A quick note is that we usually split this as shown here into two categories. The domain, which you can think of as our set of possible inputs or what we start with, in this case it's our list of countries, and the codomain, which you can think of as our set of possible outputs, or our destination, which in this case is the group of leaders. Can you name all these leaders? What do the songs Castle on the Hill, Shape of You, and Perfect have in common? They were all sung by Ed Sheeran. This is an example of a many-to-one relationship. Who are the superheroes in Avengers Infinity War? Captain America, Iron Man, the Hulk, Spider-Man, Scarlet Witch, Black Widow, Thor. I can go all day. This is an example of a one-to-many relationship. And probably in this case, we should call this a one-to-many relationship. How about what options do fast food restaurants have on their menus? Probably burgers, fries, and chicken. But you can get these at almost any fast food store nowadays, can't you? So the relationship is many to many. If you noticed, each of these examples characterize 4 different types of relation, and identifying these is pretty straightforward and will score you 1 or 2 marks in your exams. Here are a few examples of what you will likely see as an exam question, in which you only need to identify the type of relation shown. Bear in mind that one-to-one relations, or objects with no relationship, can still be present in any of the 4 types of relations. That's all there is to it, really. Now I'll show you 2 applications of the one-to-one relation. This is not examinable, but it is an important part of a branch of mathematics called group theory. Now imagine we have a classroom with 5 seats. Then, imagine that a group of students enters the class and each of them sits on 1 chair. Now, if every student was in a seat, what can we say about the number of students? We can conclude that the number of chairs, 5 in this case, is equal to or more than the number of students. Then flip that statement around. If every seat had a student on it, we can then also conclude that the number of students is equal to or more than the number of chairs. Putting both of them together, if each student is paired to exactly 1 seat, and each seat is paired to exactly 1 student, it means that the number of chairs and students in the room are all equal. Notice that we didn't even have to count the number of students entering the room to know that there were 5 of them. In other words, if we have 2 groups of objects, x and y, and we know that all objects in x have a one-to-one relation with the objects in y, and vice versa, then both groups must have the same number of objects in them. Now extending that question to a more general one. Take all the numbers along the number line. Are there more even numbers or odd numbers? Unlike the classroom example, we cannot simply count the number of chairs and students to see if they are equal, because there are infinitely many odd and even numbers. How should we approach this question? Using the same logic as before, we split them into 2 groups, odd and even. Then, we need to check that 2 statements hold. First, that all odd numbers form a one-to-one relation with members of the even number group. This is easy, as you just have to add 1 to the odd number to make it even. Then, we have to check that all even numbers form a one-to-one relation with members of the odd number group. And they do. So this gives us our answer, that there are an equal number of even and odd numbers, without us having to lift a finger to count them individually. What other applications of this counting method can you think of? Can you think of other cool properties of mathematical relations? Well, that's all for this video. Remember to stay curious and always follow your dreams. I'll see you in my next video.